So factorising is probably another one of those topics you've done before A-level, but it might just be worth going through some harder examples. If we start off with a relatively straightforward one, this is an example of where you have a term in x squared, but with no coefficient in front of the x. So you're going to get two brackets, both of which start just with an x. Now, the common approach to these is you want to find two things that sum to whatever your coefficient of your x is, and that multiplied to whatever your constant is, or your c, if you like. So in this case, we want two things that multiply to -6. So we could think either of like a -1 and a 6, or a 1 and a -6, or a 2 and a -3, or a -2 and a 3. Now, if we want these two things to sum to -1, then we can already rule out some of these. So both of these with 1 and -6 and -1 and 6, we can both rule these out as they're going to go to either 5 or -5, right? So then we're left with these two, and of course this one on the right here is going to give you 1, whereas this one is going to give you your -1, which you want. So we can just plug these two numbers into our brackets. So one of our brackets would be x plus 2, and the other bracket would be x minus 3. Moving on to a harder example then, this is a case where you have some kind of coefficient in front of your x squared, which makes things a little bit more complicated when trying to figure out what numbers to use. And in this case, we can make use of the product of the first coefficient and this constant at the end. So if we do what is a multiplied by c, so doing 2 multiplied by -15 would get -30. And we know our b, in this case, or like the coefficient of our x, is -1. So what we can do now is again think of two factors that would multiply together to give this AC product, and add to give the coefficient of our x, or b, if you like. So in this case, we could see that would be -6 and 5. So how do we use these two numbers? Well, we can rewrite our expression out, but instead of writing -x here, we could write it as the sum of -6x and 5x. So we could write 2x squared minus 6x plus 5x minus 15. And then from here, the neat thing is that you now have kind of two parts which share a common factor. So if you were to look here, you could see that both of these bracketed terms have a common kind of factor of x minus 3. So in this second one, there's obviously it's obviously multiplied through by a 5, and in this second, or in this first bracket, it would be 2x multiplied by x minus 3. So now we have two terms in terms of x minus 3, so we can essentially take this common factor of x minus 3 out in front of this kind of whole expression, and then our second bracket would just contain 2x plus 5. Of course, you could probably do this without using this AC method, so you could just write out what you would expect your brackets to be. So if it's a 2x squared, you'd expect to have a bracket with 2x and a bracket with x, and then kind of sort of by trial and error see what you would put in each bracket. So again, you know you want to get a net kind of -1, and you want something that will sum to 15, so you could be thinking along the lines of like 3 and 5, and then obviously if you multiply your 3 by a 2, you get a 6, so if you want to get a 5 minus 6, you could get x minus 3 here, which would multiply with that 2 to get a minus 6, and a 2x plus 5. And that just comes with experience as well. Now finally, we have a very important example, which is commonly known as a difference of two squares. And this comes up loads and loads, especially in A-level maths. So it's really important you get used to recognising these. So you can recognise the difference of two squares because you have two squared numbers and one is subtracted from the other. So here you've got x squared, obviously squared, and your 4 is also a square number, and you're subtracting the 4 from the x squared. And we can simplify this to x plus 2, x minus 2. Because if you think you want two things that multiply to make your minus 4, so 2 and minus 2, but if you were to sum them together, you'd get 0, so there's no coefficient in front of your x, so your x essentially disappears. This also applies, of course, to two squared letters. So if you had x squared minus y squared, for example, we could do exactly the same thing. So we'd have x plus y and x minus y. And also if you had two numbers, so let's say you wanted to compute 64 minus 25. Well, you know 64 is just 8 squared and 25 is 5 squared. So we could write this as 8 minus 5, 8 plus 5.